Hey guys, so cycle 2, week 1, made in the shade and round we go using the Cornerstone Educational Supply lesson plans. So since this is week 1, just make sure, and most of you guys are new this year, make sure you read through this lesson plan really carefully the night before so you're really familiar with all the parts of it, even down to the materials that it lists that you're going to have. So I'll have the thermometers already labeled for you as it calls for, and the kids will all have pencils to write on a lab sheet with, and the littlest kids will have one sheet in a shop ticket that you guys can write as a class on and erase. So that's no problem. Or just maybe one sheet actually to write on, not in a shop ticket. Okay, so you're going to want to just read through the vocabulary yourself so that you're familiar with it. This is not a part for you to read to the kids. This is so that you know what you're talking about, so that you understand the concepts. And then we get into the actual doing of the project. And I forget if last year they did this, but they really have done a good job this year of putting in here questions to ask the kids. So make sure that I highlighted them myself, and you might consider doing the same so that you remember to ask some of these questions. Because remember, the big point of science in CC is just learning how to ask good questions and trying to inspire that awe and wonder. So it's the question asking that's really the highlight and the focus of what we're doing in hands-on science. So the first thing we're going to be doing is we're going to be going outside, assuming that this is a nice day. If it's not a nice day, and for the video, we're going to be using a lamp. But assuming it's a nice day, you're going to be going outside to find a shady spot and a sunny spot. Whether that's just right outside the building on the sidewalk, under the awning would be shade, and then step outside of that. Or whether you want to go all the way out behind the building to the wooded area. I'm going to leave that up to you. Whatever you want to do is fine. You might consider going to the back to the recess area because the next activity that we're going to do this same day requires a large space, so that would provide that for you right then. So maybe if you go around to the wooded area to find your shade and your sun. So the first thing you're going to do is gather the students in the shade and tell them about how you're going to be learning about thermometers and measuring temperature. And then you're going to walk them out into the sunny area, and you're going to talk about how does it feel out in the sun? Does it feel different? How is it different? So just getting those little wheels turning in their heads. So the next thing you're going to do is you're going to place all 4 thermometers. So each class going at once will have 4 thermometers. And you're going to place them all in the sun at the same time. And you want them all on the same surface. So if you're out there next to the parking lot, don't put some on the asphalt and some on the pine straw. They need to all be on the same kind of surface so that the measurements are all equal. So for right now, I'll just, to demonstrate, I'm going to use my lamps. So this is the sun. And so while those are cooking, you can either be just look at your watch and note the time, because they need to be under there for 2 to 3 minutes. Or you can actually use a timer on your phone, whatever you want to do. But while those are cooking in the sun, there's some really great discussion that you can have that's just written in here. And guys, just because it's written here doesn't mean you have to say it. So this is another thing that you'd want to do the night before, is just run through and maybe highlight the parts that you think you'd like to say. So these are just guidelines. You don't have to say any of it if you don't want to. But use these as a base point. Make it easy on yourself and use this as a guide. After they have cooked for a while and you've finished your discussion, the kids, I'm going to do it starting with Caitlin's class and older, are going to record your findings on our little chart. So everyone will have a pencil, everyone will have a chart, and you're going to read all the thermometers. Then they're for sure going to need help reading the thermometers. I would say, you or an adult read the thermometer first, and then you could pass it around and try and teach the kids how to read it and how to see it. But make sure an adult does it, because you wouldn't want the temperature to change while the kids are all looking at it and passing it around. And then they're just going to record their data on the little sheet. We've got a sun side and a shade side. Then you're going to move all of your thermometers into the shade. So if we happen to be inside because the weather's terrible, then you're going to want to get way out from under the lamp. Way out from under. Or maybe even turn it off and get out from under the lamp. And outside, get into the real shade. Again, make sure they're all on the same kind of surface. And preferably the same kind of surface that you had in the sun, if possible. If not, at least if they're all on the same surface, that's better. Again, 2 to 3 minutes. There's discussion to do while you're waiting. And then at the end, you're going to record your findings again of what the thermometers reflected. After that, there's some more discussion about their final observations. And for older kids, I'm going to leave this to you whether you want to do this or not, whether you decide your kids are the older ones. They're going to calculate the average. And even for the younger kids, I want you to do it or to have a parent calculate the average so that they can see the average. And it walks you through this, and it walks you through questions to ask to find the average and why that matters. And then it goes into talking about how meteorologists record temperature data. So that's sort of what we're boiling this down to is that meteorologists always take temperature gauges in shade. And this explains why, about how like if a cloud went over in the sun, then it would change the temperature just a little bit. And so there'd be all these fluctuations all day because of cloud cover coming and going. So to get the most accurate readings, they always take temperature readings in the shade. So that'll be a really interesting conversation. And again, it gives you more questions to ask the kids to think through those things. It's really good, a really good layout there. So that's the first of the 2. The second one is called Round and Round We Go. You're going to love this. So you're going to need some kids. And so since I can't demonstrate this, and I don't really want to do it with my kids because I want it to be new to them when they go do it with you guys, I'm going to use dolls. Dolls. So you're going to have 2 students stand at each end of a rope, okay? So this is the rope, but obviously they're going to be at one end or the other. They're going to hold it pretty tight, but not doing tug of war. And one student is the Earth. We'll say Barbie's Earth. And one student is a satellite. And so we want the child to walk in a geosynchronous orbit, which means that the satellite student, this little guy, will walk in a circle around the Earth student, keeping the rope tight and always looking at the face of the Earth student. So the Earth is moving, the satellite is moving, and they're always staying facing each other. So that means that they have to move their bodies as they're turning. Okay, so that's not too hard to understand. And then there's some discussion happening while they're doing that. You could let them walk all the way around because it's a pretty long rope, so it'll take them a minute to walk her all the way around. They don't need to be running, just walking. You're going to be able to talk about satellites. It's in here, and then the next time after they've gone around once, you could have the kids take turns so that they can all do this. That's totally fine, depending on how much time you have. You're going to add a 3rd student, so that's my pig. So he's going to stand kind of in, it says, about 1 foot away from the Earth student, which is very close. So my pig is standing very close to Earth. And for every 2 steps that the satellite takes, so for every 2 steps that he takes, this student takes 1 step. And this is going to take a little coordinating, I think, especially for the littlest kids. So you may want an adult to be walking with, for the younger kids to be walking with the satellite child and this child. And this child is representing a low Earth orbit. So for every 2 steps he takes, this guy takes 1. And so he'll need to like duck under the rope, when necessary. So you are going to be discussing how, and you're counting how many times the low Earth student goes around the Earth as compared to how many times does the satellite get to go around the Earth in the same, like he goes around one whole time. Well, in that time, how many times did this student go all the way around the Earth? It'll be obviously not 1-to-1 by a long shot. So then you talk about those low Earth orbiting satellites. So both of these students are satellites. One's just further away. And this one is low Earth satellite. So you're talking about the difference between those, and there's great discussion that they have in here that you can talk about. Again, if time allows, then go ahead and let kids take turns doing these things. Maybe they would need parents on the first couple times and then they would get it. So this is not a running activity. So as always with science, you want to set expectations from the very beginning. So you can tell the kids that it's really important that we're walking during this and that we're listening also while we're walking and participating. So just remind them of those things. So this should be a great week. Thanks, guys.